Another tutorial, and in this tutorial we'll be learning about how to paint in Compose using shaders. So let's learn about this another amazing cool way for painting your pixels and rendering the graphics on the screen called and we use this shaders to do that. Okay, so we will be talking about shaders. We will be also talking about the Android graphics shading language called AGSL. We'll be learning the basic of AGSL. Then we will be learning about gradient shaders, like animated shaders, like how to use shaders for UI effects. This is like what we will be going through. You can see the preview here. Okay, so let's go step by step. The first thing is, what is shaders? Okay, shaders. What are shaders actually? Shaders in Jetpack Compose offers a powerful way to create a custom graphics and visual effects directly on the GPU, that is a graphics processing unit. So this leads to high performance rendering, especially for complex effects. Okay, so Android provides a simplified way to write shaders using the Android graphic shading language called AGSL. So the basic structure of AGSL is this is the basic simplified structure of a AGSL shader. So AGSL is based on GLSL and is designed to be more accessible for Android developers. As you can see here, you can this is a simplified structure of AGSL shader. So this is like val shader. You just pass in as a comment, and just define annotate this language as AGSL language, and just needs to pass this structure. Okay, so actually in this structure you have this annotation. This is very important. This annotation will just define this language you are using is Android graphic shading language AGSL. Okay, and then you have this tells this particular annotation tells the Android Studio actually that to enable syntax highlighted for AGSL. Okay, Android graphics shading language. Then you have a uniform float. Okay, this uniform float to resolution. This is a uniform variable that holds the width and height of the composable. So this usually holds the width and height of the composables. And then we have this half 4 main, that is floating to float to frag code. Okay, so this main function is a that is executed for each pixel. This is the main function that is executed for your each pixel. And then you have a frag code, and this represents the x and y coordinate of the current pixel. And then half 4, this represents a color with 4 components, that is red, green, blue, and alpha. Okay, so this is it, guys. And then let's jump about a simple example, shader red square example. So if you just see there, this one is a simple red square example here. Okay, here so this code actually, as you can see here, just defines a simple shader that returns a solid red color for every pixel, as you can see here in the preview. It uses the runtime shader, this runtime shader, to create a runtime presentation of the shader, and a shader brush to use the shader for drawing. Okay, so this is, we have a runtime shader and a shader brush that is used for we use this shader for drawing. So we draw with CAS in this canvas, like draw with CAS modifier. This ensures the efficient caching of the shader object. As you can see here, we can just draw into a draw scope with content that is persisted across draw calls, as long as the size of the drawing area is same, or any state of objects any state objects that are read have not changed. Okay, so this is it, guys. This is very simple example of how do we use shader. Now we can also go more further with the gradient shader. So this is our gradient shader. You can see the code here, which is pretty much creating taking two colors, that is starting and the ending color, like two colors, color 1 and color 2, that is red and yellow for the example. This actually example demonstrates a gradient shader that smoothly transitions between two colors. Okay, like it smoothly transitions between two color, right, from red to yellow. Okay, so we just define our shader shader language here, and then in our canvas we just draw with gas or draw behind, like you just use this runtime shader and shader brush to draw it, right? Yeah, we use runtime shader to create the runtime representation of the shader, and shader brush to use the shader for drawing. So as you can like as you see more further, there is a mix function here that actually interpolates between the color based on the pixel position. Okay, and the position is this one fraction, like the distance. Okay, so this was all about the gradient shader. So now let's move on with the animated shader. Inside the animated shader, we add a time uniform to the shader and use it to create a oscillating effect. Okay, mm, with infinite we always use the similar structure, like runtime shader and shader brush, and draw with cache. And with this infinite animated frames, frame milliseconds composables is used to update the time variable of every frame, driving the animation. Okay, as you can see here, with frame nanos we applied for infinite animation policy by calling the coroutine is one. Okay, now let's talk about how can use apply shader effects to entire composable hierarchies using a graphics layout modifier and its render effect property. So for that we use this a noisy shader, as you can see here. This noisy text we have this runtime shader. We have defined this shader language here as like shader using this graphics shader language, and then we use this let's see our noisy shader extension function. We use this custom modifier noisy shader extension function that takes a runtime shader and a time value. So the modifier uses draw content to draw the original content of the columns first, then it creates a shader brush from the runtime shader. Shader, this is a runtime, so we create a shader brush from the runtime shader and draw a rectangle over the content using our draw a rectangle. Okay, so the blend mode, this is the blend mode. The blend mode is set to source at top to ensure the shader effect blends with the current and the content. Okay, and this is how it works. We always use with infinite animation with frames, and this is our noisy text. Let me just zoom and check it out, guys. So this is we have this noisy text effect using the shaders. So yeah, Shader provides a vast landscape of creative possibilities. Okay, so you can also go through. There is a very cool website called Shader Toy. This offers like a lot of examples, so you can just try out the techniques and effects. So yeah, it's always you can learn through experimenting. So it's always nice if you just go and practice more. So for the documentation, you can just go and check out the Jetpack Compose developers.android.com official documentation talking about gradients and shaders. So that's it guys for now, and catch you up later guys.